NASA is worried that something strange is going on with the magnetic field of the Earth. Between South America and Southwest Africa, there is a huge area with lower magnetic strength, leading to an odd dent in the Earth's magnetic field that is splitting and growing. For years, experts have been puzzling over this anomaly known as the South Atlantic anomaly. But why does the Earth's magnetic field have such a large area with lower intensity? Why is it so important for NASA to keep track of the anomaly? Last but not least, and most importantly, does the South Atlantic anomaly have any effect on life on Earth? Earth's magnetic field works as a shield, deflecting high-energy particles sent out by the Sun, and making it possible for life to grow on our planet. Without this field, the Earth might look like Mars does now. The geodynamo process plays a significant part in the formation of the Earth's magnetic field. Through the geodynamo process, a planet can make a magnetic field. However, the planet must meet certain requirements. It must have an internal energy source that causes convection currents within the liquid core, a conductive fluid in its interior, and a rapid rotation rate. Luckily, Earth meets all of these requirements. The upper core of the Earth contains an ocean of molten iron that lies thousands of kilometers below the surface. As the planet spins, the liquid iron moves, which creates electrical currents that make up the Earth's magnetic field. This field then causes more electric currents, which create more magnetic fields. This creates a loop of electric currents and magnetic fields in the core that can keep going on its own. But the magnetic field that Earth makes is not always the same. The African Large Low Shear Velocity Province, which lies 2,900 kilometers below the African continent, is a massive reserve of dense rock. The reason for the South Atlantic anomaly is this strange construction. Large Low Shear Velocity Provinces, or LSVPs, are huge features that are deep in the mantle of the Earth and can be thousands of kilometers long. Their name comes from the fact that earthquake waves, especially shear waves, travel through these areas more slowly than through the mantle material around them. This is due to variations in temperature, makeup, or both. Let's think of Earth as a stacked sphere to better understand LSVPs. The crust covers the mantle, which in turn is covered by the crust. The core is in the middle. The mantle is a huge area of hot, semi-solid rock that moves very slowly. Seismic waves, which can be caused by earthquakes or other things, travel through these layers and tell scientists important things about the Earth's interior. LSVPs are found at the bottom of the mantle, close to where it meets the outer core of the Earth. There are two very big buildings. One is under Africa and is called the African LSVP. The other is under the Pacific Ocean and is called the Pacific LSVP. These structures are significant because they can change how things move in the mantle, affecting things like plate tectonics and mantle convection. The African province is almost tens of millions of years old and is about 1,000 kilometers wide. It has clear borders and is spread out over thousands of kilometers. It is thought that this thick structure, which lies between the hot liquid iron of Earth's outer core and the stiffer, cooler mantle, can affect the movement of the melted iron, which helps create the planet's magnetic field. Over time, these rocks can cause the strength of the field to weaken dramatically. Also, the speed of liquid iron in the outer core tilts the Earth's magnetic axis about 11 degrees away from its axis of spin. The Earth's magnetic poles are not fixed like the Earth's physical poles. Instead, they tend to move over time. Scientists think that this tilt in the magnetic axis adds to the loss of the magnetic field, which in turn could be to blame for the anomaly in the South Atlantic. The Sun's release of charged particles and plasma could also be a reason why this area has a low magnetic field. When these materials from the Sun hit Earth's atmosphere, they get stuck in two donut-shaped belts called the Van Allen belts that go around the planet. These bands keep the particles in place so they can travel along the Earth's magnetic field lines, which bounces them back and forth between the poles. About 400 miles, 645 kilometers, from Earth's surface is where the outer belt begins. Typically, this aids in keeping charged particles away from our planet and its satellites in orbit. The Van Allen belts, however, can become extremely charged during especially strong solar storms, leading to the distortion of the magnetic field and allowing charged particles to enter the atmosphere. According to a study, A limited field with the polarity turned around could get stronger in the South Atlantic anomaly region under these conditions, making the field much weaker than in other places. At the moment, there are a few possible reasons for Earth's magnetic field anomaly. Still, many questions remain. For example, a study done in 2016 found that the South Atlantic anomaly is slowly moving toward the northwest. The anomaly is also not only moving, but it is also splitting in half. In 2020, satellite data from the European Space Agency showed that the South Atlantic anomaly is splitting into two different cells, each with its own weak magnetic center. The South Atlantic anomaly, SAA, doesn't seem to have a significant effect on life on Earth, but it does make it hard for satellites and other spacecraft to travel through the impacted areas. Because the magnetic field is weaker in this area, charged particles from the Sun can get into these devices more easily than normal. This could cause serious short circuits and other problems. The International Space Station also goes through the anomaly area. Its interior and people are well protected, but some equipment outside the ISS, like the Global Ecosystem Dynamics Investigation (GEDI) mission, can be affected. For example, the South Atlantic anomaly is known to mess up GEDI devices in a big way. Because of this, a lot of data can be lost and important parts can be broken for good, so spaceship operators always shut down systems before entering the anomaly zone. The anomaly must therefore be closely monitored. The South Atlantic anomaly has been around for a long time. Some studies show that it may be a magnetic event that happens over and over again and has been happening on Earth for about 11 million years. This suggests that the SAA is probably not connected to the turning of the Earth's magnetic field, which can happen as often as every 10,000 years or as rarely as every 50 million years or more. Even so, there is still a lot to learn about the anomaly. Monitoring the SAA is crucial because of the significant and unusual changes it is going through right now. NASA is already doing this and is keeping a close eye on this strange event.